Hello everyone. In this video, we would like to discuss checking the equality of real numbers. This might sound a trivial topic given what we discussed in the previous video on relational operators, but it is not as trivial as it might sound. So the topic is checking equality of real numbers. Suppose let's do something. Let's actually check something or a calculation on MATLAB here. Suppose I ask in MATLAB to calculate sine pi, and in fact, before doing this, I'm gonna type format long. The purpose of format long is that it ends the real number up to about 17 digits. So, for example, if I type x equal 0.9 times 1.6057 3. The answer, as you see here, it gives you as many digits as possible. All right, so let me actually ask MATLAB to calculate sine pi. If you remember, MATLAB by default uses radians. And then if I ask it to calculate sine pi, the answer should be 0, as we know from mathematics. But if I actually do this, to your surprise, I get a number that's not exactly 0, but it's very close to. It is 1.22 times 10 to the power negative 16. This is a very, very, very close number to 0. This issue in numerical calculations is called round-off error. Round-off error. And the reason why there is round-off error is because of the limited amount of memory that the computer allocates to storing a real number, right? So because of this, the exact number cannot be represented on the computer. Another classic example is calculating 1 over 3. So 1 over 3, there is no way you can represent this number accurately. It's not a MATLAB issue, it's a computer issue. So the decimal expansion of this number should be 0.33333 infinitely. But of course, an infinite number of digits cannot be represented on a computer. And because of this, there will always be some sort of round off. All right. So that means because of round off error, numbers are not exactly represented on a computer. All right. And this creates a big problem when we check the equality of real numbers. So for example, if I asked MATLAB, remember last time in the previous video, we discussed the relational operator double equal sign, which is checking equality. Of course, that works very well, very, very well with integers. So if you try to use this with integers, things are perfectly fine. But the problem is when you try to use this with real numbers, now you will start face some issues. So for example, if I ask MATLAB, does sine pi equal 0? The answer to your surprise will be false. The reason for this is, as we just saw, that sine pi is not exactly 0 in MATLAB. As if you check the memory, it's not exactly 0. We can even remember that we typed this a while ago. It's not exactly 0, and because of this, the relational operator equality checking doesn't work. But this creates an issue. So let's analyze this issue in depth in the previous page. In another page. So suppose I have two numbers, A and B, and I want to ask MATLAB whether they are equal to each other. If they are integers, no problem. If they are real numbers, then there is really a problem. The problem is that because of round-off error, there is no way that these numbers will match exactly. And because of this, let's now abandon programming for a second and do some sort of math. I'm trying to check whether A is approximately equal to B, and it's approximately equal because of round off. So that, in a sense, means I'm trying to check whether A minus B approximately equals 0. Now, I can do this checking by checking whether the absolute value of a minus b is less than a small number, some small number, so some small number close to 0. Because if the absolute value of the difference between a and b is a very, very small number, that automatically means that a minus b approximately equals 0, which automatically means that a is approximately b, which means that a equals b. That's the best you can do with real numbers. So for real numbers, you cannot check exact equality. Instead, you can check that the difference between the number is small than some small number. So let's actually apply this to the case that we currently have. I'm trying to check whether sine pi is equal to 0. Then I can transform this into checking sine pi minus 0 in an absolute sense is less than some small number. Okay, and then because this is 0, so I can translate this into checking whether sine pi is less than, some small number. Now, let's actually test this. Let me clear this. I'm trying to check that the absolute of sine pi is less than some small number. The question is, how small is a small? So let's start with something like 10 to the power negative, maybe negative 9. So let's make this small number is 10 to the power negative 9, which means I am saying that if the difference between two real numbers in an absolute sense, because I'm taking the absolute value here, is less than 10 raised to power negative 9, then I will consider these numbers as equal. Okay, and in fact, if I ask MATLAB if this is the case for the absolute of sine pi, it will tell me yes, it's true. And because of this, I will consider that sine pi equals 0. Now, someone might wonder, well, 10 to the power negative 9 might not be small enough for you. So you might want to make a tighter difference. So you might need to check whether the difference is less than 10 to the power negative 10. I would say that's fine. Okay. It's a tighter criterion, which means like really from all practical point of view, let's say from a science and engineering practical point of view, if the difference is less than 10 raised to the power negative 10, then I would consider these two numbers equal. In fact, let's test this. And yes, it's the case. You might keep thinking that tightening the equality criteria as you make it smaller and smaller, this will be more rigorous. In fact, it's yes. But watch out, because if you make it too small, very small, it will be as if you are checking equality to 0 again, which is problematic for real numbers. So my recommendation is that you always check for some small number, and from experience, it seems that, let's actually do this on another page, it seems that checking that the difference is less than 10 raised to power negative 14 is sufficiently rigorous, because really 10 to the power negative 14 is a very small number. So if the difference is very small in that sense, then they should be considered equal. So it's a very rigorous. And on the other hand, it still avoids the round off issues that we discussed. So for example, I can check that the absolute value of of sine pi is less than 10 to the power negative 14. And in fact, yes, you can make it even tighter, negative 15. But watch out now, because if we try to make it tighter, let's say 10 to the power negative 16, it will tell me false. Because the difference between sine pi and 0 is not less than 10 to the power negative 16. The reason for this is that sine pi, unfortunately, because of round off error, is actually greater than 10 to the power negative 16. Let's actually remind you of this. You see, it's 1.2 times 10 to the power negative 16. So obviously, the difference between sine pi and 0 is not less than 10 to the power negative 16. So this is too tight. Because of this, my recommendation is that the small number that you use for checking purposes is 10 to the power negative 14. On one hand, it's very rigorous, and on the other hand, it's not very, very small to the extent it makes round off problematic. So let's recap. If you have two numbers and you are trying to check their equality, if the numbers are integers, then it's totally fine to use the relational operator double equal sign. But if the numbers are real numbers, then because of round-off error, you must really check that the difference between these two numbers in an absolute sense is less than some small number. And the recommended small number in typical engineering and scientific practice is 10 raised to the power negative 40. Thank you so much. This is a very, very important video. I strongly recommend you to study this one very carefully, and see you in another videos.